So what they do, they break the network, big network to small, according to their requirement. But this solution gave rise to another big problem, that internet routing table increased tremendously. So for this they designed another solution, that is Xpedient, that is classless inter-domain routing. Classless inter-domain routing helps ISPs to summarize all those small routes into one big route and advertise that one single route to the internet. So the problem has been solved a little bit. But the main driver to slow down the pace of IP address assignment is NAT. NAT is network address transmission. What it do, it maps single or pool of public IP addresses to the thousands or you say millions of private IP addresses. Its solution seems very good, that IP addresses that we need previously cut down a lot by this technology. But this technology has some inherent problems. As this guy has suggested, NAT does not support many of the applications. And NAT is not application friendly. So for example, if voice over IP you are targeting, you cannot run voice over IP if you deploy NAT in your environment. You need public IP address. So this solution says that IP address assignment is still growing, IP address pool is filling up. How you can say that what are the trends of internet growth? Here from the graph you can see that if the growth was linear, it will take around 14 years, like January 2021, all IPv4 address will be exhausted. But this graph says that growth is not linear, not exponential. It is polynomial. This is the actual trend. So this trend says that after 2009, means 2 or 3 years after from today, you have no more single IPv4 address. Means not a single device can be connected to the internet. What about wireless? How you can deploy wireless technology in this environment to you address 58.6 million subscribers only in Pakistan, billions of billions in the whole country, or we can say the whole world. So this is the point where Internet Engineering Task Force says that we have to go for something new solution, not this netting or something like that. What we need bigger, very bigger IP address space, and that is IP address. The trend says it's going polynomial, but how it's going polynomial? What are the basic reasons? The basic reasons that not only data service provider or ISP are going for the IP-based services, even telco operators. What are the basic responses? They need to sell only voice services. Why they need data service? Let's take an example of mobility. This is a mobility infrastructure that, let's suppose this is site in Karachi, this site is in Lahore. Initially when they designed the network is based on TDM infrastructure. DSM is TDM infrastructure. But the problem is that as their network grows, there is around more than 3,000 sites in different cities of Pakistan. How TDM can manage this amount of traffic? It's a huge overhead, or the bandwidth management is not that up to the mark. What they do, they shift their TDM infrastructure to KDM infrastructure. But KDM doesn't gonna help them a lot in the next few years. So they are planning now to shift their KDM core to IP-based MPLS core. This will be mobile network in next, you can say, 2 or 3 years. So mobile operators need IP infrastructure. Next slide. These workers, you already know WiMAX. WiMAX is IP-based solution. So the next feature of the team telecom network will be like this. That base station is there. The base station doesn't need MSC or BTS. There is a single base station. And that is a wireless switch that is connected to router, and the whole infrastructure is IP. So if both WiMAX will help, that there is a the difference between telco operator and data operator. That is, they offer data services and the telco operator offer voice services. One team offers both with a single platform. That is unified communication, converged network solutions. If, for example, a corporate network is a headquarter, you can say this is my branch office and this is me. I need to communicate, I want to move, going to my client, and what I need to access some emails or some of my data files from my headquarter. What I will do, I just connect my wireless enabled laptop to the working network. I just dial my VPN to the headquarter and get my files. At the same time, suppose I have to call my colleague in the branch office. Do I need mobile? Do I need new phone? No. But he is there to offer voice services over wireless as well. I will use my wireless enabled mobile that will be soon launched by 2008 or 2009, and I will dial using the same infrastructure. Even though if I want to use my home network, single mobile can help me to control all of my home appliances, that is electrical home appliances, using my single mobile. For example, my fridge, my refrigerator, any electrical device can be controlled through IPv6 via my single mobile. This is the future, and this future can only be addressed through IPv6. Other than that, what are the emerging applications? These are the real practical examples, especially from Japan. And Japan has introduced IPv6 card. This card has IPv6 enabled. Means all the way to the track you have internet access. You have emergency, you can say if you have fuel, you need fuel, you can GPS system available, you can do anything you want. PlayStation, TV, toys, voice over IP solutions, even refrigerators and ovens have IPv6 enabled, and these are implemented in Japan. So you can see that normally these things we used to see in the movies like Back to the Future and something like that, these are actually implemented in Japan. Why not here in Pakistan? What other benefit IPv6 will help me to one? IPv6 help me because it is scalable and flexible. Why it is scalable and flexible? Because it can address a huge number of IP addresses and hosts. We see how long it is. It improves the performance, it improves security. Most of you probably hear about IPsec. Do you know what is IPsec? IPsec is the world-renowned security protocol probably used for encryption and tunneling techniques. This is by default implemented built-in in the IPv6. You don't need to implement IPsec separately. Mobility. IPv6 is designed for wireless, for mobility. So mobility, that is mobile IPv6, is built-in IPv6 for better management than IPv4. In previous slide we see that why we need IPv6. It is necessary because wireless is there. Now we need to know how IPv6 will be implemented and what are the technical details. IPv4 and IPv6 comparison. Let's take it first. IPv4 is 32-bit address. 32-bit address means maximum of 4 billion hosts. Practically it is only 250 million. Whereas IPv6 128-bit long address. How long it is? It is 340 trillion.